So, a very good morning to one and all present here. This is Mr. S. Hariharan, working as an assistant professor in the Department of Electronics and Communication Engineering, Knowledge Institute of Technology, is feeling much proud and privileged to welcome our today's chief guest. The world needs strong women, women who live and build others, who will love and be loved, women who live bravely, both tender and fierce, women of indomitable will. With the quotes, I would like to welcome our today's chief guest, Dr. L.S. Jayashree ma'am, who is working as a professor in the Department of Computer Science and Engineering at PSG College of Technology, Coimbatore. And ma'am has completed his Bachelor's of Engineering in the Department of Computer Science and Engineering and Master's of Engineering in Computer Science and Engineering. And also she is holding the doctoral degree, which she has completed in the domain of Computer Science and Engineering. She is an expertise in Internet of Things, applied soft computing, machine learning, artificial intelligence, cognitive analysis, and assistive technology. And ma'am has published more than 40 research papers in both national and international journals, and also in various conferences, with a citation score of 393 and H-index score of 58 and I-10 index score of 8. And on behalf of the management, Knowledge Institute of Technology, and on behalf of Dr. P.S. Srinivasan sir, principal and founder, and on the behalf of the head of the department, Professor Dr. N. Sandhya Kumari ma'am, I wholeheartedly welcome Dr. L.S. Jayashree ma'am to take over the session. I welcome you, ma'am.
Thank you for the nice introduction. A small correction, I did my bachelor's in electronics and communication, and my research domain was in wireless sensor networks. Anyway, thank you for the introduction. And my H-index and I-10 index has reached, I think it is 10 now. Fine. Good morning to all the participants. Good morning to one and all. Thank you, KIOT faculty, for inviting me again for this Atal FDP. Before starting the session, I have a small request. Can we all remain silent for a minute to just pay tribute to the commanders who lost their lives yesterday in a very unfortunate air accident right here in our own state. Shall we? Thank you. Good morning to you all once again. I am Jayashree, working as a professor in the Department of Computer Science and Engineering in the PSG College of Technology, and I also happen to be the convener of the Institution's Innovation Council. And I also head a department, it is not a department, it is a Center of Excellence called as DST's Center of Excellence for Assistive Technology and Rehabilitation Engineering Solutions. So with this introduction, so this is going to be a broad agenda outline of today's presentation. So we'll spend a few minutes on to just understand what is edge computing, how it is going to have its interplay, role of interplay along with cloud computing, how it is going to complement the cloud computing, and what is connected or otherwise called a smart healthcare, and the role of edge computing in the connected or smart healthcare use cases is going to be the main focus of today's lecture. We'll also touch upon the research challenges so that the participants who are interested to pursue research in this particular area can pick up a few research ideas or some hints so that they can pursue their research in this particular very interesting upcoming and emerging area. And a few sample case studies, which are our own projects, which are attempted by our own Center of Excellence. So we'll have a look at these case studies as well towards the end of the session. So the session duration is 1.5 hours, right? So what is the total duration of the session? It is for 90 minutes, right? And up to 11 o'clock. Am I right? Okay, anyway, so I'll try to complete it by 11 o'clock. Now we're starting at 9.
Ma'am, you can take up to 11:15 or 11:30, ma'am. The actual
completion. Okay. Okay. So I plan my lecture only for 60 minutes and for the demo part for only 15 minutes. Let's see. If at all there are questions, I think I'll be happy to answer the questions towards the end of the session, because handling a session at a stretch for 2 hours, I don't think it is going to be effective. So if it is going to be interactive, then it would be fine. It will be mutually beneficial to the participants and for our own side as well. So will try to make it more interactive, as
And
interactive
they
as
will
possible.
interact surely for the past 3 years. Only because of interaction, the session gets extended beyond 2 hours also.
Oh.
Okay,
Okay,
ma'am.
madam.
Thank you.
Thank you. Yeah, let's get started with this agenda. So, this is a broad picture of any IoT use case, be it domestic IoT application or healthcare IoT application, or an industrial IoT application, or be it a civic IoT application like a public an IoT use case that is built to cater to the needs of the public services like water quality monitoring or structural health monitoring applications and so on. So whatever be the use case or application, so this is going to be a broad picture where you have where we have a huge number of IoT devices deployed in the actual working environment, and it keeps generating the data. So it is all about the data, and the data that is generated from these huge number of IoT devices are to be analyzed properly in order to gain some intelligent insights about the trends and patterns occurring in the data. So it is all about the data and the insights which we are going to derive from the data. So as far as businesses are concerned, this particular the insights they are going to derive is going to be very useful for them in the sense that they can build better business models, they can monetize the data, they can monetize the insights, they can take informed decision making, business decisions, and so that they can gain an they can gain an edge over their competitors. So it is all about the data and the way in which we are going to process and analyze the data in order to get in order to gain a better understanding about the pattern of the data. So this is going to be the major or undercurrent in whatever IoT use case that is considered. Okay, so it is about the devices that are generating data and doing the analytics analysis to gain the proper insights about the data, the trends, patterns, whatever insights, whatever intelligence we can derive out of the data is going to be the crux of the whole thing. When we talk about data analytics in IoT, so we can do it in several different ways. So it could be as simple as a descriptive analytics where we answer very simple questions. That is, whenever some event happens, descriptive analytics is very simple, where it will just try to say to the stakeholders, it will just notify the stakeholders that a particular event has occurred. Okay, it will not tell anything more than that. It will simply notify the concerned stakeholders that a particular event has occurred. Okay, it might be an indication about a faulty valve in an industry IoT application, or it might be when a threshold in a health monitoring application, when some vital signs exceeds the threshold, then just sending a notification to the caregivers about the occurrence of that particular event. So it is something like that. So it is as simple as that. And when we move up to the diagnostic analytics, as the name implies, so it tries to diagnose the reason for a particular event. So when an event of interest has occurred, diagnostic analytics tries to relate that with the root cause of the problem. It tries to do the causal analysis. Okay, so whenever there is an event, it tries to understand, it tries to help understand the reasons for the particular event that has occurred. Okay, so that is about diagnostic analytics. And predictive analytics, as the name implies, it tries to predict when a particular event of interest is likely to occur. It might be an event like a failure of a machinery, or it might be some desirable event or whatever. So it tries to predict by means of several predictive models. So it tries to predict when actually an event is likely to occur. Okay, that is about predictive analytics. And finally, this is a more sophisticated form of analytics where it is called as prescriptive analytics, wherein it tries to give answers to, like, say, for example, it tries to give recommendations like an AI-based expert system. It tries to tell when actually, how actually an event can be made to occur. If it is, say, for example, if it is a desirable event, then what are the reasons that particular event, what are you supposed to do in order to make that event occur? And if it is an undesirable event like a failure of a machinery or an equipment or or whatever desirable, whatever undesired event that is of interest, then it tries to explain what not to be done in order to prevent that event from occurring. So that is about it is like giving prescriptions. Okay, so it is about prescriptive analytics. So as you move up in the insight hierarchy, from simple data processing to gaining more and more better understanding about the data, about the trends of the data and the patterns of the data, you gain more and more wisdom, and this is where all these AI and ML algorithms that come into picture. So okay, in all these data processing frameworks, so this is the central, this is the framework that is being followed in general. This is the conventional model that is being followed in IoT data processing, wherein you have a set of a plethora of IoT sensors, embedded devices, and so on. So as they keep generating the data, all these data will be transported to a remote cloud, so that all these analytics can happen in the cloud. So all the raw data that is getting generated from these things will move to the cloud, which will be available several kilometers away. So the cloud server is a place where all the data analysis takes place. So all the raw data that are generated from these devices will move up to the cloud through some appropriate gateways. So here the point is that all the raw data is moved towards the cloud. Maybe this gives a slightly better picture where actually the things produce data, and the gateway, they simply forward the data. These IoT gateways, it could be as simple as your smartphones or a custom built IoT hardware which acts as a gateway. So whatever device that is acting as a gateway will simply forward all the data that are getting generated from these smart gadgets or IoT devices, sensors, actuators, and all that. So they not actuators, only sensors. So the gateways simply forward all the data that are generated from these devices, these smart things, over to the cloud, and the cloud server processes the data, it analyzes the data and takes some control action. So it is actually a closed loop, right? Closed loop. All IoT use cases are there to provide some control actions based on the data that is gathered. Some insights are gained, and based on that, some control actions need to be initiated, like closing of a faulty valve, or shutting down a machinery, or say turning on an insulin pump when blood glucose level increases beyond a threshold value, and all that. So some kind of actuation needs to be, control action needs to be initiated. So data is processed, it is analyzed, and the control actions are sent back to the concerned device through the gateway. So this is how the centralized data processing architecture is envisioned, or this is how it takes place in a centralized architecture. And several use cases are built on top of the data that is being processed. So for remote monitoring and control, several use cases may be built. So this is a centralized architecture where all the raw data moves up to the cloud, and it is only at the cloud all the data processing is taking place. And the cloud server here is assumed to be available several, say, thousands of kilometers away, which is usually the case. Okay, you may have your private cloud, but normally when in an outdoor IoT application where you are dependent on a distant cloud server which is placed several kilometers, several hundreds of kilometers away. So when such applications are concerned, so what are the drawbacks? What are the drawbacks in having such a centralized architecture where all the data processing takes place only at the cloud? So these are some of the challenges involved in IoT data handling in a centralized manner. Okay, when you have such a centralized architecture, which you have just seen, so these are some of the issues or complications that arise because of having a centralized architecture where all the data processing takes place only at the cloud. So of course it is about the security, because you are moving the data over the air to a distant place, to a remote place. So these data, they are vulnerable to attacks. Even the devices are vulnerable to all types of security attacks. Privacy, because this could be a wearable device, and it might invade into the user's privacy. So there are different types of devices that are being used, including cameras and all that. So privacy is an issue, and interoperability of these devices, over-the-air upgrades, huge data volumes, real-time actionable insights, standardization of these devices, because there are different types of devices that are coming into the IoT ecosystem, and different devices different devices generate different formats of data, and building or integrating all these into a unified framework, and there are still no standards that are mature enough. The standards are not mature enough to develop a unified framework wherein all these heterogeneous devices can be integrated together. So these are some of the data challenges, and maybe we, since our focus is not about handling this particular topic, we'll just touch upon this thing where what is going to be the implication of having huge amount of data that is getting generated. And that is one of the drivers for moving towards edge computing. So when we talk about this particular issue, when we focus on this particular issue of the devices that are generating huge volume of data, just to understand how huge the data is going to be. So let us see a few use cases where, say, when you take the case of connected transports, connected cars or self-driving cars, which have more than 200 sensors on board. So they may be generating more than, say, around 2 or 4 terabytes of data per day per car, and oil wells, onshore, offshore oil monitoring, oil and gas pipeline monitoring applications. So they might be generating, each oil well might be generating, because they should be having a huge number of sensors to monitor the health of such oil and gas pipelines, the plants and all that. So they will be they are expected to generate on the average, it generates 10 terabytes of data per day per oil well. And you take assume that imagine the case where an oil and gas industry are having so many number of such oil wells under their control. So each such well will be generating 10 terabytes of data per day, and weather monitoring application, it is expected to generate 5 petabytes of data per day. Aviation, airline industry, with more than 6,000 sensors on board, it is expected to generate 2.5 terabytes of, it is only an approximate amount of data volume, just to give an indication. Windmills generating 5 terabytes of data per day, and another mode of transport. So shipping industry, they are generating, on the average, they generate 1.5 terabytes of data per day, and healthcare application is no exception. Even though here we have not indicated the data that is getting generated from smart healthcare applications, where actually we are going to see that in the subsequent slides. But when we talk about the amount of data that is getting generated from different use cases, even though healthcare industry is not matured completely into a smart healthcare industry as on date, when things get, when we are going to envision so many smart wearables and smart healthcare monitoring devices coming into getting their presence into the IoT ecosystem, they also are expected to generate so much of amount of data, even though at present they are not generating this much of data, because all these industries are already well matured. They have they are all typical industrial IoT applications. They already have huge number of sensors and embedded devices into their day-to-day operations. Healthcare industry is also moving towards such a case. And it is projected that even healthcare, we have all these figures and stats that are coming in the subsequent slides. So the one of the challenges that we are discussing now in terms of dealing with a huge amount of data is not, it is equally applicable to the healthcare industry as well. So that is the takeaway here. So that is what we are going to see. So this is about the massive amount of data that is getting generated. So what is the implication? So when we say that a massive amount of data and huge number of sensors are getting involved, and they keep generating lot of data day in and day out, every second, every minute, and so on. So what is the real challenge? What is the actual challenge in dealing with such a huge volume of data? So, so this is the reality. In processing of the IoT data, in processing of the data that is getting generated from the embedded devices and IoT sensors, when we have, what we actually have is an infrastructure where the connections come and go. the connections are intermittent, right? Even in our urban settings, we may or might not have felt this particular, because the day in and day out we are connected through virtual platforms. Even here with established setups also, we face a lot of difficulties every now and then, right? But just assume the case where these the connectivity that is taking place in say remote areas, hilly terrains, and not so well connected geographical territories. So the quality of the connection is not so good, right? So students also keep complaining about that, right? That is a fact of life, right? So we are the data transport requirements keeps increasing, but our infrastructure is not keeping pace with the amount of data that is getting transported over the air, right? So the quality of the connections is not still not so good. Not all the places are equipped with 3G and 4G infrastructure. Not to, even if you forget 5G infrastructure and all that, even 4G connections or 3G connection is also, so many places are still starving, and the complete, there is a digital divide between the urban and the rural areas still, right? So the connections, the quality of the connection is intermittent. The connections come and go. When you talk about IoT applications, be it an industrial IoT application, or even healthcare is also an industry, it is also they also want to get profit out of that, and at the same time they want to give better patient experience. So in use cases like healthcare, and even if you forget about healthcare application use cases, even in other not so like critical applications, like monitoring the integrity of the structures, like say the long spanning bridges or skyscraper buildings and all that. So structural health monitoring applications are connected transport application, water quality monitoring application, or water quantity monitoring and all that. So these are typical outdoor IoT applications, right? Remote mining operations. All these will suffer from the intermittent from the loss of the data connections, right? When the connections come and go, when the quality of data connections keep changing. So because of these intermittent connections, what actually happens is that, so what is its implication on the data that is getting transported? So one thing is that the data, the existing infrastructure is not sufficient. The bandwidth is not sufficient to handle such a huge volume of data. As we talk about terabytes and petabytes of data that is getting generated from various different IoT use cases, and it is still going to be on the rise only. So it is not going to decrease at any point of time. We still, as more and more devices are getting added to the IoT ecosystem, the amount of data that is going to be generated from these devices is going to only increase. So, but whether our infrastructure is sufficient enough to handle, to handle such a huge volume of data. So there is always a difference there. There is always the bandwidth that is available at our disposal is definitely not sufficient to deal with such a huge volume of data. And added to that, we have intermittent quality of connections. So the data over the air gets lost from time to time. We lose data, and when there is a bandwidth insufficiency, it automatically increases the latency of the data. Latency is nothing but the end-to-end transfer delay, right? So before the data actually reaches the cloud, it would have already, say, a few minutes or few hours of delay. So in some of the mission critical applications, like say moving a robotic arm over the air, in some industry controller mining applications, or even in healthcare applications, where we even talk about performing telesurgeries, remote surgeries, and all that. So when there is a delay in taking an action, okay, it is equivalent to taking no action at all. That is an action that is taken a few minutes. An action that is taken in a delayed manner is equivalent to taking no action at all in some of the mission critical applications, including healthcare applications, right? So when there is an insufficient bandwidth, it automatically increases the network delay. So the implication of that will be on the delay of the, it introduces so much of undesirable delay on the transport of the data. So we don't get real-time insights. In some applications of like surveillance application and all that, robotic control applications, where real-time getting a real-time insight or performing a real-time action is so crucial. So when there is a delay, then automatically that application, the data loses its value, because the data is perishable. In such cases, data loses its value when it is not used on time or when it is not used appropriately. So when there is a problem in getting real-time insights, some of the real-time use cases will definitely suffer. And security and compliance also. Security we already know, it's a broad topic, and security we can understand, and compliance is different countries will have different regulations in dealing with human data or even industry data. Like even different countries have different policies regarding if it is a drone flying kind of use case where you so certain surveillance drones are deployed. So different countries will have different flying procedures, drone flying procedures for commercial operations, right? And not only in the case of autonomous drones and all that, even dealing with patient data, human data also, different countries will have different regulations. So when your cloud server is placed in a different country, then there is actually an incompatibility of compliance in terms of compliance of rules and regulations, right? So that is again one of the policy issue. So high latency is what we've understood, what we've discussed already. So these are some of the challenges that we need to deal. That are to be dealt in a centralized data processing architecture. So when given the fact that these are the problems, so what is the solution? So the solution is that instead of moving all the data from the cloud, all the data from the devices to the cloud, okay, wherein a centralized architecture is involved, we can move towards an architecture where it is decentralized, in which the selected data only move to the flow towards the cloud, and most of the data processing can take place near the source of the data itself. Okay, so as much of data to the extent possible, we can process the data near the source of generation data, source generation of data itself, and only the insights. After drawing insights from some of the real-time analytics that are performed, only the insights will flow towards the cloud, and it is not the actual raw data that is moving towards the cloud. So when we assume such an infrastructure, when you go for such a decentralized architecture, most of the problems we discussed a while back will be overcome. Say for example, so this is actually the broad picture of how actually we can move from centralized architecture where it is only cloud-based processing to a decentralized architecture where edge devices and fog devices are involved. So this architecture now becomes like so you have things here at the things layer, and in between the things, the smart things and the cloud, we introduce some of the devices which are called as edge devices. They are similar to gateways, but the only thing is that now the gateways will we in the previous case we assumed the gateways simple data forwarding agents, but here the edge devices, it could be your smartphones or any other, say Arduino based or Raspberry Pi based some custom built hardware. So since they have sufficient computing power with themselves, so why not leverage the compute and storage capability available with these edge devices themselves? Edge devices are the devices which are directly connected to these smart things, right? So normally in all our IoT use cases, we use our smartphone to gather the data and transport it to the cloud, right? So instead of sending all the data, raw data to the cloud, and for the cloud to take care of everything, instead of the cloud to take care of everything about processing the data, why not we leverage the processing, store and storage capabilities that are available right at the edge devices, which are available closer to the data point of generation of data. Okay, it is only one hop away from the things, the smart devices or IoT sensors and whatever. So they are just available at one hop away, within a few feet of, within few meters away. So as much of data processing to the extent possible can take place at the edge devices themselves, and you can have one more layer in between, or you can even be these fog devices can be dispensed with, because edge itself acts as both as data aggregators as well as data forwarding devices. All the networking functionalities may also be incorporated inside the edge devices. So they are available within few meters from the point of generation of the data. So they do whatever analytics that are possible at the edge device itself, and then only the insights will flow towards the cloud. And of course, the selected data. Whenever there is some control action that needs to be initiated only from the cloud, some remote configuration, we'll see all the how the edge and device is going to interplay. That we will see. Before that, we'll just revisit the challenges which we discussed a few slides back, and how it is actually getting overcome in decentralized architecture. So first of all, the problem of the insufficient bandwidth is getting alleviated, because now the problem of big data, dealing with a huge volume of data in different velocities, different varieties. So all the heterogeneous data, dealing with such heterogeneous data in a huge volume is getting is made simpler by means of processing the data at the edge devices themselves. So the big data becomes smaller. So your bandwidth insufficiency is not going to be a problem at all, because you are reducing the amount of data that is getting transported all the way to the cloud is reduced enormously. So that is one thing. And the problem of having intermittent connection quality is also not going to pose serious threats, because you are leveraging the nearest computing capacity that is available at the edge devices. And processing data, since you are processing the data closer to the data source, you can get real-time insights about the data. Okay, instead of involving the latency. I mean, latency is not a problem now, because the processing happens closer to the source of the data itself, so that you can take real-time control actions wherever required. You can take immediate control actions. And assuming the use cases like self-driving cars and all that, taking an immediate control action is so crucial. It is so critical, right? So you cannot wait for the cloud to take an control action whenever some real-time action needs to take place, like applying a brake or turning, whatever. So in such cases, processing the data closer to the data source itself gives a lot of advantages. And high latency in transmitting a huge amount of data is getting reduced, because you're reducing the amount of data, the latency also, because your latency is directly proportional to the size of the data and indirectly proportional to the bandwidth of the data. As the bandwidth increases, latency will decrease. But bandwidth is not in our control. We have to live with whatever bandwidth that is available. But you can reduce the size of the data. So when you reduce the size of the data, latency also gets reduced. And since your data stays at the source, only insights flow towards the cloud server over the air. You need not worry too much about the compliance and regulations. Privacy is not going to be at stake. Privacy of the data or invasion of user privacy and all that is not going to be a big problem. And you get near real-time insights, and you can take real-time decisions appropriately. Instant actions are possible. So these are the advantages of going into a decentralized architecture, where we involve or we try to leverage the computing capacity and storage capacity that is available in our smart devices, which are going to collect data from the IoT devices. Instead of simply forwarding them to the cloud, they will do as much data processing as possible, and then only they derive some insights about the data. Say, for example, whenever a control action needs to be initiated from the cloud, or so now the point is that whether we can do away with the cloud. Is the cloud server becomes dispensable when we have so much of advantages associated with having edge devices or edge computing in place. The answer is that the edge computing cannot be a substitute for cloud computing. It can only complement the cloud computing, because you need cloud servers. You have to have cloud servers, because all the in order to build good prediction models, accurate prediction models, you need huge amount of historic data, right? So your edge devices will definitely not be having such a huge storage capacities. You anyway need data centers. Okay, so in order to build good learning models, and when we have to have machine learning and AI in place, that is when we are going to use machine learning for analyzing your data, in terms of say prediction models or classification, whatever. So you need a huge amount of data to train the models, right? So such huge data is available only at the cloud, not at the edge device, because this is only a temporary storage, only for real-time control actions. You may leverage the power of edge computing devices, but for long-term storage of data and for training the machine learning models, you need huge amount of data that is that is getting stored in your cloud servers only. So the point is that the training of the machine learning models can happen at the cloud, while the execution, the actual execution of when some control actions are to be taken, you already have the learned model. So the actual execution of the machine learning algorithm can happen at the edge, and the training can happen at the back end at the cloud server, and only the learned model will move on to the edge devices, and the edge devices when it sees a situation when it needs to take an action, then it will use that learned model which is available, and the actual execution or actual decision making will be happening at the edge computing devices. But the backing has to be provided by the cloud anyway. So this is a sample snapshot of how what type of say how you can interplay, how edge and cloud can interplay. Okay, how they can complement each other. So simple data processing like data filtering, data cleaning, noise removal, data aggregation, real-time insight analytics, and some amount of cognitive intelligence and analysis using text, voice, video, images, and all that can happen at the edge devices. Whereas remote monitoring of all the edge devices that are deployed in various because if an industry may own several hundreds of such edge devices, and they have to remotely manage all those devices from the backend cloud server. So the remote management of the edge devices and configuration over their upgrades and visualization and reporting, long-term analytics. Or so these are some of the tasks that can be performed at the cloud server, and these are some of the modules that can run at the edges. So this is only a snapshot. This is only indicative, not comprehensive. So this might give an idea of how actually we can interplay with the cloud and edge server in any general use case, not specifically to healthcare or whatever. Yeah, before moving further, are there any questions regarding whatever we discussed so far? And these are some of the challenges that needs to be held at that needs to be handled at the edge. So the replication of the data, how much of data has to be made available at the edge, and how much of data has to be transported to the cloud, what kind of data can be moved towards the cloud, and what needs to be retained at the edge itself, when the data has to be moved to the cloud, and how much of data, at what interval. So all these are the business logic will decide, the policies will decide how actually the edge and cloud will interplay with each other. And so on the security at resource constrained edge devices, because edge devices are constrained in their resources, you cannot run sophisticated security algorithms to safeguard those devices. So they are vulnerable to attacks. They have storage limitations, and you are creating analytical model in one place and executing it in multiple places. So that is learning the model, learning the model from the huge amount of data that is available at the cloud server, and creating an analytical model out of that in one place, that is at the cloud. And actual execution is going to take place in multiple places, in multiple edge devices or edge servers or edge gateways. Okay, and creation and exchange of machine learning models, complexity management. So all these are some of the challenges. Anyway, we'll towards the end of the presentation, we have one more slide that discusses about the research challenges that have to be paid attention to when we talk about edge computing, maybe in the perspective of healthcare applications. Okay, so before moving on to the second part of the presentation, are there any questions or shall I proceed?
Ma'am, you can proceed, ma'am.
Yes, thank you. Okay. So the second part of the presentation deals with how this edge computing is expected to transform the healthcare industry. Again, it is not going to be a very exhaustive presentation. Maybe we'll touch upon a few aspects of it. Okay, how it is going to benefit the stakeholders. The stakeholders involving the patients, the healthcare service providers, hospitals, pharmaceutical industries, and whoever is involved. So how it is going to benefit them. So these are some of the stats. The global market for IoT medical devices is expected to exceed $500 billion by 2025. So the point here is that even medical industry is going to produce so much of data. The amount of data that we see now at present from the medical industry, from the healthcare industry, it is going to increase by leaps and bounds in the years to come, like other industry use cases which we have seen. Okay, it is also going to generate terabytes and petabytes of data per day from the various connected medical devices. So we have to, this medical industry also should be ready to deal with such the various problems involved in moving the patient data from one place to another. According to WHO, the world is aging, right? The world is aging, the population is increasing, and at the same time, the population of the senior citizens is also increasing. So the projection of WHO is that the number of senior citizens will increase to about 1.5 billion by the year 2050, which means that, which actually implies that as we have more and more aging people in place, so the need for the hospitalization needs will also increase. The need for taking into account the chronic diseases or chronic disease management, the need for chronic disease management, continuous monitoring. So all these will also be in the rise because of this implication of aging population. More and more at-home healthcare services will also be on the rise, right? And it is not only about maintaining the electronic health records, because this digital healthcare is not something new. It has been there for past 1 or 2 decades. So digital health records, wherein we make use of the conventional mobile devices or mobile applications, smartphones, and other devices where which are used to move the patient records, like their laboratory reports or health reports, their immunization charts, and whatnot, their insurance, health insurance data, and all that. Okay, so all these records are already maintained in the cloud server, and we have very good portals where we actually the hospitals, they can manage all these electronic health records of their patients in a very effective way by means of all these digital connectivity which are in place. So that is about digital healthcare. But your smart healthcare is not just about dealing with the electronic health records of patients. It is also about dealing with so the difference between the digital healthcare and smart healthcare. So what could be the difference between these two? Is it simply about maintaining the electronic health records of patients, or what could be termed as smart healthcare or connected healthcare? Actually, this connected healthcare is slowly evolving towards smart healthcare, where the healthcare is made more and more autonomous. It is made more and more pervasive and more easy to access. So as it is found here, it allows patients to connect readily with their providers without visiting them frequently. That is, it is not about just using their mobile phones or this mobile apps or web servers to maintain their to stay connected to their health providers. It is also about, in addition to these smartphones and the web servers, staying connected with their healthcare service providers. It is also it gets added by means of adding all those wearable medical devices and even implantable IoT sensors and ingestible sensors. Okay, all these are coming into picture along with the conventional connectivity devices like mobile phones or laptops or tabs with the help of all these wireless communication standards that are already in place. Okay, it allows the patients to connect readily with their service providers without visiting them frequently. So it allows the health conditions of the patients getting monitored by their healthcare service providers automatically in an autonomous way, even without the patients needing to visit the health centers often. This just gives an idea of how much of wearable devices. So you have wearable devices, fitness monitors, vital sign monitors, tele-rehabilitation devices, in addition to the conventional mobile phones and other connectivity devices. So in the days to come, we may be using more and more of these wearable medical devices and fitness monitors in so glucose monitoring devices, blood pressure monitoring, blood pressure, smart blood pressure cuffs, and so many other vital signs getting monitored automatically, so that when something goes wrong, it can be immediately attended to. Some timely intervention can take place, can happen by the healthcare service providers without even the patient getting to know about it. And needless to say, in pandemic situations like this, where even for senior citizens and for aging people, even visiting hospital itself will become more like we talk about hospital acquired infections. Okay, so that might be even more, that might be more deadlier than their actual health condition. So visiting even healthcare facilities and hospitals is also not advisable, but still they have to be provided with due and appropriate healthcare when about their, some of them might be, they may be dealing with some chronic medical conditions like respiratory conditions or increased diabetes levels, and so many neurological and orthopedic conditions and all that. So so many of them might be under rehabilitation setup. So instead of making them visit the healthcare facilities frequently, normally a hypertensive patient will be visiting the clinics or hospitals, their physicians, say once in 6 months, and based on the whatever blood pressure level is measured at that point of time when they visit hospital, the treatment is normally given only based on the snapshot that is available at that point of time. That is only an instantaneous sample. It may or may not talk about their long-term average, right? A hypertensive patient, normally when they visit their physician, say once in 2 months, say once in a month or once in 6 months, in whatever interval they choose to. Okay, so whatever treatment they are given with currently, at present at least, it is only based on the snapshot of say blood pressure level that is acquired at that point of time. Or at some cases, the patient may be explaining the doctor about the level of blood pressure he has been maintaining. So even though we have smart blood pressure monitors that are available in the market, okay, even if they are not well connected to the healthcare infrastructure, right? They are used in a very, very isolated way. They may be having some smart blood pressure monitors where the data automatically goes to an app, but still it is all in silos, right? So it is not going to automatically, it is not getting transferred to their backend healthcare service provider. So getting a clear and accurate picture about their health condition is actually not happening at present, right? So in case when we have a connected healthcare setup where you have all these wearable and devices and other IoT based medical devices that are connected to the backend service provider, to their healthcare service provider through and as we have discussed, there are so many drawbacks and limitations associated with moving patient data from the place of generation of the data all the way to the cloud. If all this data, like the latency is a problem, and since this is a healthcare application, it could be a life critical equipment that needs to be intervened at the moment that it actually needs to be ought to be done, right? So even if a few seconds are wasted, then it might be life critical. So taking real-time decision is so critical. So instead of moving all the data to the cloud, taking a decision right away from an edge device. So you might be having an edge server or an edge gateway or a simple actuator that is available right at the place of generation of the data may do the necessary intervention in a very timely manner. Okay, so this is just a snapshot of how the patient data and by means of hospitals, when multi-hospital system or in a chain of hospitals like Apollo, and when you have such sophisticated enterprise-wide hospital chains that are available, so they might be deploying their edge servers in multiple locations, multiple places where they can keep monitoring their patients in a very effective way. They can all stay connected together so that the different stakeholders will be gaining better insights about their patients' conditions. And this data, they can share this data. Normally, it is all for gaining profits, right? So they can, this data will be shared among all the stakeholders, including the pharmaceutical industry, etc. So in order to build better business models over the data that is available. And this is another just another way of looking at it in terms of the various layers. You have the device layer, edge layer, where all these a home gateway or a hospital gateway, in edge infrastructure service providers like a small data center, micro data center. It might not be as sophisticated as a backend cloud-based data center, but it might be a micro data center where all the in a multi-hospital system, where or in a smart city kind of environment where such healthcare services, smart healthcare services are provided in a city scale, in a city-wide manner. So you need to have micro data centers that are deployed in every city, so that because a small device like a smartphone or an edge gateway might not be sufficient to handle all the data that is generated from the various patients, right? The number of patients are increasing, so they may have to have an edge gateway in order to store all the data that is generated from so many such wearable devices and IoT based medical devices. It could be standalone devices that is put into the ambience, or it could be an implantable medical implanted IoT sensor or a wearable medical device. So all of them are going to generate data, and they might have their own micro data center. And after doing the appropriate analytics at the place of near the place of generation of the data, in order to derive some meaningful insights about the data, so only the insights will flow towards the cloud, and these insights will itself be sufficient to build good prediction models about the actions that need to be taken in order to get some overall understanding about the trends and patterns that are occurring in say in pandemic situations, or in order to gain a better understanding about what kind of ailments are affected, what kind of ailments are occurring in a particular place, or whatever insights they want to gain. So all this can be done at the cloud, and you can have different use cases can be built, like a remote monitoring application or a rehabilitation service. These days, we talk so much about virtual physiotherapists and all that, where the patients or stroke survivors or patients who are affected with chronic conditions, even instead of visiting the physiotherapist physically, since everything is made using virtual platforms nowadays, even there are applications that are built where the rehabilitation can also take place in a remote manner. A virtual rehabilitation service can be provided, or even some of the medical devices, some of the continuous monitoring healthcare devices are very costly. Not each patient cannot own those devices. So this device itself can be offered as a service, and platform can be offered as a service. And use cases like chronic disease management can also be built in order to continuously monitor the vital signs of the patient, and if something goes wrong, alerting the caregivers or the healthcare service providers immediately in order to take appropriate and timely intervention. All these are possible, and different use cases can be built in order to leverage the data that is getting generated. So this is just a snapshot of what experts got to say about the power of edge computing in connected healthcare applications. So here again, the point is that the ability of the devices to compute, process, and analyze data with the same level of quality as it is done in the cloud. But only difference is that here it is done with a very, very reduced latency. We cannot say that it is without zero latency, but still The latency, that is when it is compared to cloud-based processing, it is very, very negligible. So the reduced latency gives better patient experience and improved patient experience, decreased cost, especially in cases where you need to transport medical images like MRI data, X-ray images, ultrasound images and all that. Since the volume of data involved is very high, it easily touches a few, say tens of MB or even up to a few GBs, right? So transporting such huge volume of data, even if it is from a single patient, transporting the data to the tune of a few GBs over the air is of course costlier in the contemporary scenario. So when you try to process the data near the source of generation of the data itself, say within the hospital premises itself, instead of moving all the way to the cloud, if the hospital itself has an edge server or an edge gateway that can process this data, and only the insights, that is whatever insights that are gained from the processing of the data, will be moving towards the cloud, because there might be world over, there might be several such similar ailments and medical conditions that might be present, might be present. So a unified framework and unified understanding about the ailments and medical conditions can be done by means of moving storing the data in the cloud, and whatever decision making that is done, if it is available at the cloud, then it will be easy for all the healthcare practitioners to understand the different trends and patterns that are occurring in the medical data. So decreased cost is one obvious advantage, increased efficiency in processing the data, and it all converges on giving better and improved patient experience. So this is about the driver. Just a minute. Yeah. What is driving towards edge adoption? This is one important point that can be taken, like the ability to process, compute, and analyze the data near the source of the data itself. So that is one major driver of going towards edge computing. And what are the use cases in which this edge computing is expected to have its practical impact? Okay, which are the use cases where actually this expected to have bigger impacts? Is like, say for example, one obvious use case is emergency service management. Say for example, like when the patient is transported to hospitals in an emergency condition. So the ambulance itself, when it is fitted with so many sensors and gadgets that keeps collecting the data from the patients in the golden hour itself, before he is moved to the hospital, if his vital signs and whatever medical conditions that needs to be monitored, if it is done at the ambulance itself, then before even he reaches the emergency care facility, his data will be readily available so that the emergency staff can attend to him in a more informed manner. Okay, so emergency medical care is one obvious use case, and not only that, the management of the chronic diseases, wherein the patients need to be in continuous monitoring about their insulin levels, respiratory conditions, their neurological activities, cardiac rhythms, gastrointestinal activities, and all that. So it is not going to be like, it is not an acute device. It has to be monitored over a very long period of time. And instead of when sufficient medical devices, wearable devices or implanted devices are available to take care of these things, and when they get automatically connected to the back-end healthcare service providers, not using the traditional cloud platforms, by means of having some smart embedded edge devices that act as edge gateways and edge computing devices, things are made more easy and simpler, and decisions can be made in a more and more autonomous manner. And at-home care, this is another very important use case where senior citizens are involved, and they have to be in constant care. About say that they might be suffering from some neurological or neuromuscular degeneration conditions like Parkinson's or stroke, or some other neurological conditions where they need to be at constant monitoring, but still they cannot afford to take them to hospitals at every now and then. So providing at-home care will give them a better quality of life, better autonomy, better psychological reassurance about their health condition, and all that. So this is one place where edge computing is expected to make its impact. Okay, and ICU care, of course, timely interventions are possible if all the equipment, the bedside monitors that are available are connected using a proper infrastructure, so that whenever a timely intervention needs to be done without wasting time, the interventions can take place in a very, very appropriate manner. And in a multi-hospital setup where heterogeneous devices are available and they may or may not be backward compatible with the legacy systems. And this is where collaborative machine learning and collaborative explainable AI and all that come into picture, because data is of different varieties and you have to have different learning models that are built from the different sources of data. So the ML models have to collaborate among themselves in order to give a unified picture about what is learned about the huge amount of medical records that are available throughout the world, or maybe in a large scale perspective. What kind of collaborative understanding can be done with the help of machine learning model? It is expected to serve the medical fraternity in a very, very effective manner. So this is about the challenges that need to be handled. Okay, what are the biggest challenges of implementation? Of course, ensuring enough bandwidth, not only in terms of transporting the data to the cloud, even in terms of transporting the data to the edge servers, which might be available even even few meters away. When more and more image-based data or video-based data coming out of different sophisticated medical devices, you need to ensure enough bandwidth. And the most important thing is the security of the medical devices. Since we talk about life-critical medical devices, the security of these devices, safeguarding these devices from over-the-air attacks, because now they are connected, they are more prone to attacks. When they are available in a standalone manner, you can at least say, the security is not so much at a compromise. But when they are connected, safeguarding the medical devices becomes one of the most. It is becoming one of the most important concerns. It is of paramount importance to all the stakeholders involved. So the security and of medical devices and privacy of patient data also has to be taken care. And acceptance by healthcare professionals is another big hurdle, because healthcare fraternity, they will not accept solutions unless otherwise it is proved adequately. All these edge computing solutions, whatever is getting developed towards certain use cases, they need to gain appropriate and wider acceptance by the medical fraternity by means of adequate number of trials, certifications. Regulatory authorities have to approve that. So because we have that particular industry is not used to embracing the technology in a widespread manner. Of course, technology has forwarded, but not in such a end-to-end manner where patients are directly connected to hospitals, and even without visiting the hospitals, patients are giving, they are given treatments and all that is something new to our scenario. So acceptance by healthcare professionals is another big hurdle, and it will take its own time for getting accepted. And the selection of appropriate edge computing tools. There are different edge computing platforms that are on offer, but using open source computing platforms or edge computing platforms may not be appropriate, because when we talk about the security of the devices, in order to safeguard the devices in the most efficient manner, so in some cases using open source edge computing platforms may not be advisable. So the selection of appropriate edge computing tool based on the use case is another important issue to be addressed. And of course, the question of who will pay for what service. Like when a patient is transported over an ambulance, when it is offered an edge computing based emergency care service, whether the hospital will bear the cost or the patient will be charged extra for experiencing that service. So all these are the business rules that needs to be properly defined, and the regulatory bodies have to have a proper, there should be some proper SOPs that should be well defined, so that there is no confusion among the stakeholders that are involved in a use case. And just whatever we discussed so far, so these are some of the benefits that are available to the different stakeholders, including the patients, their caregivers, the medical professionals, that is the clinicians, the service providers, the back-end platform managers, the hospitals and all that. So what are the different benefits? And of course, small use cases like reminders for taking medicines, reminders or giving recommendations about their diet plans, visit schedules, reminders. So these are some small use cases that can be built when the patients stay connected to the hospital network. And in addition to viewing their reports, prescriptions, and video audio consultations, these are some of the, you can, like when the system is all in place, there is a possibility of building huge number of use cases on top of what is already available. So these are some of the possible use cases that can be built on top of the connected healthcare infrastructure. As far as the patients are concerned, these are some of the use cases that could be done. That is because when we talk about senior citizens, giving reminders for them to follow the prescriptions, they may tend to forget. So when such reminders are given to them in order to take the medicines as per the prescriptions, and most of the cases they may even tend to miss the doses. Not only missing the doses, they may even take wrong doses also sometimes. Because of some confusions due to aging, or because of some confusions in following the prescriptions, they may take wrong medicines, and that itself will lead to a lot of health complications. So giving them proper voice-based guidance from the back end, or by means of having a good reminder app from their mobile application itself. There are so many reminders that are already available, but they can be made more and more customized, so that the reminders can be played in the within the using the voice of their near and dear ones, their kids and kings, so that it gives them a better psychological peace. In some of the cases where elderly people are living in independent settings, independent dwellings where they live alone, they want to stay connected with their near and dear ones, right? So and they want more, and at the same time they want more and more autonomy. They want better quality of life, they want better health services to them, but at the same time giving helping them stay connected with their dear and near ones will give them a lot of psychological reassurance about, and it will also help them overcome their anxiety of living alone, or fear of living alone. So there might be n number of applications that we could think of in helping the senior citizens stay connected, stay in a more and more safe and secure manner. So audio and video consultations without even making them visit hospitals. So all these are some of the envisioned applications in terms of the patient experience. It is not only for the senior citizens; it is for any other people of any others who are suffering from chronic conditions. Also, the same. The use cases will help them lead a better quality of life, receive better patient experience. And for medical professionals also, generating a treatment plan and having maintaining a very good history of their patients, and helping it also helps them in critical decision making, because now since a sufficient amount of data about their patients' medical conditions is already available, it helps in making good and informed decision making and accuracy. It improves the accuracy of diagnosis. It reduces missed diagnosis or misdiagnosis, and timely and appropriate medical treatments can be initiated. And so as far as hospitals are concerned, information sharing, sharing the information across the different stakeholders, and so these are the different benefits that you can view with respect to different stakeholders that are involved. And yeah, these are some of the live examples of the connected health devices in various forms. like each of them giving different types of services, like right from face recognition to gesture recognition, fall detection. When elderly people they live alone, detecting their falls is of course a very very important. Just a minute, getting it. Yeah, like whenever there is a fall event that is occurring, just give me a moment. Yes, fall detection is one of the very, very important services that is provided by this particular Altum View systems, and maternity care. And these are some of the other medical devices that are available in the connected healthcare ecosystem. And these are some of the service providers across the world who offer connected healthcare services. Mayo Clinic, even Apollo has its own telehealth wing, where actually they perform teleradiology, telecardiology, chronic disease management, psychiatry, tele-ICU, diet counseling, and so on. These are some of the examples of the different service providers giving different kinds of services in the connected healthcare ecosystem. This is another example where a UK-based connected healthcare provider giving so many, even including palliative care, where the patients who are in terminal stages, pain management, dementia care, and living home care, chronic pain management. So these are different services that are on offer. Yeah, coming to the platforms, edge computing platforms, just a word about the different proponents, different candidates that are available. So these are some of the popular edge computing platforms that are available in the market. So these players already have their presence strongly in the cloud, and they have also released their edge counterparts. For instance, Amazon has released AWS Greengrass as its edge counterpart of its AWS, and similarly, IBM has released IBM has Watson with a lot of cognitive analytics capabilities. Apache has Agent as its open source offering of edge computing platform. There are something like OpenWhisk and OpenFog, or some of the other open source offerings in the edge computing ecosystem. And even Cisco has come up with the IOX edge computing platform, and allows networking devices like switches or routers as edge devices. So even the traditional conventional network switches can act as edge devices, as edge gateways, with the help of Cisco's IOX platform. Okay. And whatever provisions are already there in the cloud, like data analytics, streaming analytics, advanced machine learning, device integration, all these, they are also made available at the edge. So when we have such platforms in place, whatever functionalities we used to do in cloud, like data analytics or streaming analytics, cognitive analytics, performing advanced machine learning and all that, so they can have their equal presence at the edge itself, perhaps with less carbon footprint, because we have local data centers and we can manage them in a better way with reduced carbon footprint. But the important requirement is that some of these roles can be performed by the edge and some of them can be moved to the cloud. So the rules that define which actually needs to be moved to the cloud and which has to be maintained at the edge itself should be defined properly by the business logic. But the real challenge is that the consistency, it should be maintained between the cloud and the edge in terms of their programming model. So that the data analytics or other data aggregation modules already developed for cloud can be moved down to the edge with little tweaking, like modifying a few lines of code and all that. So again, revisiting the challenges involved in edge computing in general. So these are the challenges that are out there when we deal with edge computing. This is in general applicable to all the use cases. Okay, and specifically speaking, so all these, I think we have already discussed about this discovery of the different services that are available, different edge devices that are available. There should be a proper discovery protocol. service discovery protocol should be there. The security of the edge nodes, standardization of architectures and protocols, interoperability, usage monitoring and billing, fault tolerance, and providing the adequate quality of service. All these are the challenges that are available in general. When it comes to the edge computing that is used in healthcare applications, these are specific research challenges. Some of the specific research challenges like AI-enabled tools are required for analyzing large patient data. So it should have cognitive analytics capabilities because most of the medical data are in different formats, including voice, video, images, text, and all that. And complete integration of all applications and systems which are deployed for leveraging patient data on edge. So you might have a few standalone mobile applications, and when they are connected to the backend cloud service providers, how the entire thing can be integrated together, of course, with the presence of the edge devices that are coming in between. So integration, the complete integration of all the applications and all the stakeholders that are involved, and coping up with the big data sets produced by medical devices and sensors. Security issues, of course, to protect the sensitive security as well as privacy issues to protect the medical devices as well as the patient data, and identification of the right data that is needed for each use case. So all these are some of the research challenges that are that should be taken care in the perspective of the smart healthcare with the help of edge computing. And this particular slide, okay, this gives an idea of the challenges that are involved. This was prepared with the manufacturing industry perspective, but whatever is available here is equally applicable to the healthcare industry as well, because the industry standards, since we don't have standards that are mature enough to deal with all these, so the lack of industry standards to define the legal, social, and ethical aspects of using edge intelligence, that is still not, it is very, very nascent stage. It is in a primitive stage, so there should be proper standards, and there should be a proper IT infrastructure, especially the backward compatibility with the legacy systems, be it industrial systems or any other use case is concerned, connecting it with the backend legacy servers. It is also another challenge, dealing with security and privacy and software frameworks. So it is not only applicable to the, these are considered as the factors that restrain the adoption of the edge computing in a larger scale, not only in the manufacturing point of industry point of view, in any use case for that matter. These are the challenges that needs to be properly addressed before the widespread adoption of the edge computing use cases. So moving on to the last stage of the presentation, last phase of the presentation, where we'll be just looking at a few sample case studies. Especially these are the a few sample projects that are developed at our own center, which is called as the DSP's Center of Excellence for Assistive Technology and Rehabilitation Engineering Solutions. Just give me a moment, I'll take a sip of water. So we have a center that is sponsored by DSP in our own college. So we have attempted a few projects which deal with the assistive technology and rehabilitation engineering. And we will also see how actually edge computing plays its role in these of the projects which we are going to, a couple of projects which we are going to see now. The role of edge computing, maybe you can relate where actually edge comes into picture in these projects as well. The first project is a wearable gait assessment and fall prediction device, which was developed with the help of DST seed funding. That is the technology intervention for disabled and elderly wing of DST. With the help of the DST funding, the problem is the elderly fall. The problem that was taken into account is elderly fall, where the fall is considered as the most serious problem, and adults more than 65 years of age, they suffer the greatest risk of falling. So preventing them from falls, from likely falls, remains as one of the highest healthcare priorities. It is not the fall that is occurring due to environmental hazards or poor lighting conditions or any other such cases. It deals with the falls that are occurring due to aging and due to some weaknesses that are getting developed due to some various health conditions like neuro or ortho-degenerative disorders and so on. Okay. So the solution that was developed is called as a wearable device, which is called as Gatewatch, which is actually a patented device. So it is a smart wearable knee band, which is used to actually monitor the gait conditions. Gait is nothing but the walking phase of an elderly. Maybe we can see the details in the subsequent slide. This device is actually has passed all the wearable device testing standards like EMI/EMC testing, specific absorption, biocompatibility, and other ethical clearance has also been obtained from PHG medical hospitals for human trials. It is a class A device with less than minimum risk involved when it is applied on human beings. So the objective of this device is to quantitatively measure the gait wellness markers. So when a person walks, there are a few gait related parameters or nothing but biomechanics. Okay, human biomechanics that could be captured in order to understand how well their gait is or how healthy they are in terms of their walking and or what is going to be their risk of fall, likely risk of fall. Okay. So we can estimate a fall risk based on the various gait parameters in addition to their pre-medical history, medical conditions like what kind of ailments they are suffering already, whether they are using any mobility support aids, whether they suffer from any cognitive impairments. So based on factors, qualitative factors like these, their medical history along with the spatiotemporal data that is getting generated when they wear this device and walk for a brief session. A lot of useful gait related parameters can be captured using the inertial sensors, and from that we can derive the fall risk score of that particular individual. And here is the actual the overall methodology from the inertial sensors. Their angular velocity in three-dimensional coordinates, their positioning, all the phase and rhythm-related gait parameters can be captured. They can be extracted, and from that, using an appropriate internationally recognized fall risk prediction model, and it has been enhanced so that the what is already available is completely subjective, and we have modified it to make use of the objective parameters that are captured using this device. So in addition to the qualitative data, the quantitative gait markers will be used in order to derive a fall risk score. And there is an app associated with that. There is a mobile application which will be used to fetch the patient details and whatever. Yeah, when the device is worn like this, it is actually a device that is wearable just below the knee, and as they walk, their gait parameters will get captured. And in addition to their preclinical data, combined with the medical history, along with the data that is captured from the real-time walk session. So as I told, a fall risk score will get generated, and all these will take place only at the device itself. So this is an example for an edge computing device. There is no need for transferring all these parameters over there to the cloud, because this itself, with the power of semiconductor industry, we have very powerful embedded computing development boards that are available. So instead of wasting the computing and storage capacity available at these devices, they can be leveraged so that all these calculations and all these parameter, all this filtering calculations can take place by the edge device itself, and only for report generation and for long-term storage of the patient data. Because when these this kind of devices are used by many citizens across a given city, then all these are need to be stored at the cloud server so that the history can be tracked, right? So what is their fall risk score at this point of time, and after a month later, or say after 6 months later, or after 1 year later, after they're given some proper therapeutic interventions, how their gait is improving. So in order to keep track of that, anyway, you need to store the data in the cloud, right? Only the reports will be passed on to only the reports will be stored in the cloud. All other calculations shown here will take place only on the device itself. And a mobile app will just be used to get the user data and to finally display the report. And the report will look something like this. Okay, so the various parameters associated with their data, including the step count, and this step count is not something that is similar to what is calculated using our fitness monitors. It is an accurate count that is measured using, tested against a test rate, biomechanics test rate. Their cadence, that is the steps, number of steps taken per minute, the velocity of the walk captured from individual legs. It is not born in a single leg. It is born in both the legs, so that the individual parameters can be captured from both the legs, because doctors felt that for some patients, one leg will be dominant and one leg will be supporting the entire body in case of a weakness. Okay, in that case, in such cases, you can see gait asymmetry between both the legs. Okay, as you can see here also, there is some asymmetry that is present, and so the various gait related parameters will be captured in order to finally assess their fall risk. Fall risk score, based on that, their fall risk can be assessed, so that appropriate mobility support aids can be intervened. They can be intervened with providing them with mobility support aids, so that a likely fall can be prevented. And these reference values are derived from a huge number of trials that are conducted for a given age, for given height, weight, and gender. What is the normal value, and how much their their instantaneous value is deviating from the normal value. Based on these, using a patented algorithm, the fall risk is getting generated, and it is shared with the concerned stakeholders. So this was actually one of the devices that is selected for mass production and commercialization by DST in May 2020. They even released a press note in the PIB portal of Government of India regarding this. This actually shows a very early stage prototype where the size of the device was huge, and the fastening mechanism was not very user friendly. But over the last 1.5 years, we have improvised it as very aesthetically and appealing and ergonomically very easy to wear. So the technology was actually transferred to an industry for mass production and commercialization. So after appropriate number of field trials conducted, we got ethical clearance from the PSG IMSR ethical clearance wing, that is institution's ethical clearance wing for human trials. It was cleared for use on human beings, and we conducted. We are still conducting more and more clinical trials, because as we get more and more data, only the models which we are working on can be made more accurate. So the prediction or the fall risk score that we are generating will improvise only based on because even if you refer to papers, they publish data. Only very few papers are available in this particular aspect. We found only one Japanese paper where they published the reference values for the different human beings of different ages, but still that is for a different race, right? For Indian conditions, what is going to be the normal value that has to be derived only based on the sufficient number of clinical trials and field trials conducted, right? And even at the Salem Neuro Foundation, we keep conducting for all the outpatients and outpatients visiting the Salem Neuro Foundation. Maybe your college is available. You must be knowing about this Salem Neuro Foundation. So all the outpatients that are visiting this facility, they are this is the device. So and it comes with an associated mobile app, which is available in a tab, and the patient data is getting entered into the tab. And when they are made to walk after wearing this device, and it is a very brief walking session of duration, say 30 seconds to 1 minute. It could be as low as 30 seconds in order to generate the report. And once that walking session is over, the report is getting generated, which can be viewed in the right away in the mobile app, which gets instantaneously generated. So maybe you could have understood the way in which edge computing is leveraged in the perspective of this particular application. And there is a demo also. Moving on to the second project, it is about the design and development of a wearable intelligent navigation guidance kit. Actually, this fall predictor is a part of this project. The larger part of the project is about developing a device for wearable intelligent navigation guidance kit for preventing the problem of wandering in elderly people suffering from dementia. This is just an introduction. So just start. So I'm just skipping. So the problem that is actually addressed here is how to deal with the frequent spatial disorientation and wandering problem of elderly people or whoever is suffering from dementia. And dementia is a broad term. This frequent spatial disorientation of EWD, that is elderly with dementia, actually implies a lot of anxiety to their caregivers, because they need to be in constant need for surveillance, and whenever necessary they have to intervene so to bring them back to their homes, right? So this frequent spatial disorientation is a problem that needs to be addressed in order to ensure safe and independent outdoor mobility of patients suffering from mild to moderate stages of dementia. Okay, so instead of caregivers always paying attention to whenever they are venturing into an outdoor mobility, instead of giving a lot of stress to their caregivers, if they are they have the independence to move on their own and coming back to their home on their own, then it will give them it will improve their quality of life and it will increase their independence in outdoor navigation. So this is the basic problem that is addressed. And again, this is an overall methodology that is involved. So the caregivers, they are given with a mobile app wherein they will be provided with the facility to to define a geofencing boundary. Okay, so through this app, caregivers can define a geographical boundary, which actually refers to a safe boundary for the elderly to navigate. Okay, within this boundary, they are safe. They are ensured. They have as per their history of outdoor navigation. Within the geographical boundary, that is a geofencing boundary, they are expected to reach back to their homes without any intervention. But they go outside the geofencing boundary, then it will automatically start giving voice cues so that voice-based navigation guidance will be given to them, so that they can, instead of depending anybody else to reach back their homes, even in case of spatial disorientation, it will automatically help them to reach back to their homes. Even within the geofencing boundary, sometimes, say for example, depending on the time of the day or depending on their stress levels, even within the geofencing boundary, and actually speaking, this could be a dynamic geofencing boundary which is learned using a machine learning model based on their history of wandering, based on how they behave over a period of time. This geofencing boundary itself can be made more dynamic so that it gets adjusted to itself by means of learning their pattern of wandering. Okay, so in that case, even within the geofencing boundary, based on their stress levels and time of the day, say for example, in case of night times, even stepping out of the door is considered to be a wandering episode. They need not even cross the geofencing boundary. So stepping out of their homes in an untimely manner itself caregivers have to be notified about that, and voice cues have to be initiated. So depending on these parameters and geofencing, depending on their current location, it will be decided whether it is a safe wandering or non-safe wandering. The non-safe wandering will be decided based on all these parameters: environmental conditions, their current stress levels, time of the walking, and their current lat and long, their current geographical positioning. So it will be decided by the algorithm whether it is a safe wandering or non-safe wandering. In case of safe wandering, it will just keep monitoring the trajectory of the EWD. In case of non-safe wandering, it will intervene by means of giving voice-based instructions, and also it gives a notification to the caregiver's mobile, so that instead of that physically going and attending them, they can keep monitoring their trajectory in their mobile phones, in the mobile app, so that they can make sure that they reach back to their homes automatically, and in case they will have to intervene only when it is necessary. So since they are given a provision of reviewing their real-time trajectory of the EWD, they can have a psychological reassurance that they are navigating back to their home in a safe manner. Only in case of necessity, the intervention will be initiated by the caregiver. So that is about the mobile app that is available at the caregivers. This will be useful for two purposes. One, to define the geofencing boundary, and the other one, whenever there is a wandering episode, in order to track real time about their current location. Okay, and even history is stored in the database, and that this again is a local database. It is not a cloud database. So the device itself will store the location of the EWD in a given wandering episode, so that they can backtrack in case of an intervention that is necessary. They can actually, this is not visible here. This is actually it shows location of the EWD in various points of time. So by means of backtracking, they can even whenever there is an intervention necessary in order to bring them back home, so they can keep track of this wandering database in order to get to know when they were, where they were at a given point of time. So this is actually a wandering history, and for a few episodes, all this data can get stored in the edge device itself. That is, whatever device that is available as a wearable device to the elderly people with dementia, the device itself can act as an edge device, and most of the data gets stored. At least a few episodes of wandering can be stored in the device itself. There is no need for it to move to the cloud. Only when it is necessary to do long-term processing in order to adjust this geofencing boundary, the device, the data will be moved to the cloud in order to take some informed decision about adjusting the geofencing boundary. Because as the disease severity progresses, the boundary has to be readjusted accordingly. And one more last project is about this a virtual physiotherapist project, wherein the patient can wear a handcuff. It can be made as a smart handcuff, which will keep a track of the exercise, because most of the when we talk about stroke rehabilitation and other rehabilitation, they have to undergo regular physical rehabilitation protocol. Okay, so, and instead of a physiotherapist physically visiting them, or even they going to the physiotherapy centers, from their home itself, they can do the workouts, or they can follow the rehab protocols that are defined to them. And the physiotherapist will monitor the rehab protocol, the effectiveness of the rehab from a remote place. So so all the exercises that they need to do will be listed, and from the mobile app, they can choose one, whatever rehab protocol that is defined, and if they start doing the exercise, so it initially gives some guidance related to how actually the exercise needs to be performed, either a video based guidance or text based guidance. So this defines the exercise protocol that they need to follow, and once they start doing it, since it is being a wearable device, again with inertial sensors, it can monitor the range of motion that is performed by the user, as well as the count of the exercise, how many times they have done that particular exercise, and whether they have done it properly or not, by means of keeping track of the range of motion. Okay, for a particular exercise, if they have not done a few cycles properly, then it will give them an immediate feedback to prompt them to do it properly. So once they complete a workout, it will give a summary of say the straight push we have done for 10 times, side push 10 times. So it is based on an automatic counting, okay, regarding how many times they have performed that particular exercise and whether they have done it properly with a complete range of motion or not. Okay, so this is the way that they can improve their muscle fitness, and the strengthening of the muscles can be, they can gain control over their muscle strength. So this feedback can be, this can be remotely monitored by the physiotherapist, as well as the summary will be shared with the physiotherapist, so that whatever kind of interventions they need to do, it can be automatically initiated. Yes, I'm done with my presentation. Maybe we have 5 more minutes of time, 5 to 10 minutes. If there are any questions, then I'll be happy to answer. And thank you very much for the opportunity given to present my views on this topic.
And very thank you from my bottom of the heart, ma'am. It was a lucid presentation and was very nice. And dear participants, it's your time. So if you do have any queries, you can post it in the chat box. If not, you can unmute your audio, and you have a provision for that. And if you're really interested, you just please post your queries in the chat box so professor can answer your queries. Dear participants, if you have any queries, you can post your queries in the chat box. If not, you can unmute yourself. You have a provision for that, and you can ask your doubts, if any you have, to the professor.
Good morning, all. You have the privilege to unmute yourself. You can unmute yourself and you can ask your queries or questions. Ma'am, one question from the chat box.
Yes, yeah, I'm just doing it.
Yes, ma'am.
Available database for Alzheimer's disease. What kind of database you are looking for? Can you please elaborate on that? Because Alzheimer's actually speaks about a large, it is a broad spectrum, right? So what type of specific data you're looking for? I think Mr. Deepak, one of the research scholars, has posted this question, like MRI, fMRI, which could be available in ADNA database. I'm not aware of this ADNA database because we have not worked on biomarkers. Okay, so we have, as I've explained, it is only about wandering patterns. As far as other neurological conditions are concerned, I've seen a few databases for Parkinsonian and all that. As far as Alzheimer's are concerned, the online database and its availability, I'm not thorough with that because I've not used it. I think you can simply Google it and find out. For biomarkers, I think there should be some good databases available. Only when it comes to the outdoor navigation and all that, very few databases are available. But for biomarkers, there should be adequate amount of databases that are available online. Thank you very much. Since it was a 2 hours presentation, I don't know how much was actually useful. I'm not very sure about that. I just randomly put forward my views. If you have any specific queries with regard to whatever within the scope of the presentation, then even offline also I can attend queries. Maybe I can leave my mail ID. Dataset for brain tumor. Whatever domains I've not worked on, I may not be able to comment on the availability of the data sets. And actually speaking, people, when we attempt, say, machine learning algorithm or deep learning algorithms, we are so much obsessed about using the data sets that are already available. But instead, if you could collect some real-time databases, because all these online databases, they talk about some like imported data sets. If you really, if you have a chance to work with hospitals, then collecting some real-time data from the hospitals, then that will be of very great value. And it is not that always you have to go for machine learning models. Wherever possible, please focus on deterministic model, because we are still not mature enough to use machine learning algorithms on embedded devices. It may or it may not be accurate enough in giving predictions. Instead, please focus on the deterministic models and formulas, established mathematical models that are already available. Okay, because as you know, machine learning models are probabilistic in nature. Like if you report say 90% of accuracy, Somebody else may report some on the same data set. Somebody else, when they run their machine learning model, they will get an accuracy like 70% or 60%, and there is no foolproof standard that is available to evaluate the different machine learning models. So using machine learning models for healthcare applications, especially when it is used in real world projects, it is still not considered to be very safe because if you want to build a very good learning model, then it requires a huge amount of data that is captured or gathered over several years of time. I've seen very good projects where actually people have worked on say 7 or 8 years of time, okay, in order to gather the sufficient amount of data to give proper predictions. But only with limited data, giving a prediction is not safe. Instead, you can use established mathematical standards. That is my recommendation based on the experience I've gained. Okay, Facebook link. Yes, of course. And as of now, I'll just leave my mail ID so that if you want to have any ask any offline questions also, I think it should be possible for me to attend.
Dear participants, kindly note down the mail ID.
And even our hardware, one big hurdle we faced was like the form factor of the devices. Even though we say that it is wearable device, our development boards are still not, the form factor and the aesthetics is not still gone to reach that maturity level where we can design smart wearables in the form of say watches or bracelets or lockets and all that. It is still a long-term, long-distance dream. We have not touched that level of maturity in terms of our semiconductor devices. We still have to wait for a few more years in order to design aesthetically appealing wearable devices for some good sophisticated applications. For simple applications like whatever I projected as the first use case, that was possible, but for the second use case, we were not able to reduce the size of the device. It is still huge. It is still not wearable. It has to be carried in a bag or a pouch or something. It is still not a complete wearable device. When you use Jetson kind of development boards where actually the machine learning models can be run directly, it supports machine learning, but customization of the devices is still not possible. At least with the facility, PCB fabrication facilities we have at our disposal within India. Flexible PCB still all this manufacturing, printing of PCBs, assembling, all these are still big hurdles. Yes, there are no more questions. I think we can close the session, and thank you very much once again for your patient listening and for the organizers for giving me the opportunity to talk to the participants on this topic.
We are very glad to have you.
Thank you so much.
Ma'am, with the formal vote of thanks, we can wind up the session, ma'am.
Yes.
So as we express our gratitude, we must never forget that the highest appreciation is not to utter words, but to live by them. So with this beautiful quotes, I would like to end up the session, which was handled by Jayashree ma'am, professor who is working in the Department of Computer Science and Engineering from PSG College of Technology, Coimbatore. And on behalf of the management and on behalf of our principal, sir, Dr. P.S. Srinivasan, sir, founder and principal, Knowledge Institute of Technology and Knowledge Business School, and also on behalf of my head of the department, Dr. N. Sandhya Kumari, Professor and Head, Department of Electronics and Communication Engineering, Knowledge Institute of Technology, to thank the beautiful and grateful resource person of today's session. And we are expecting your presence in the upcoming slots if we have any, ma'am. And your presentation was very fruitful, and also it is very lucid. And thank you for the valuable presentation. And you have given all the insights about the wearable devices. Thank you so much, ma'am.
Thank you so much.
Thank you so much, ma'am.